Okay, so when you think of a skilled technician, what pops into your head? Probably a toolbox, right? A hard hat, someone who's amazing with their hands. And look, that picture is not wrong, but it's definitely not the whole story anymore. Today, we're going to unpack what I'm calling the digital backpack of a modern tech professional, and what we're going to find is this fascinating story of how careers are evolving, a world where the line between being an electrician, a network engineer, and even a software developer is getting really, really blurry.
So let's just dive right in. The whole idea of a job is changing. It's not really about a static title you hold for 40 years anymore. It's more about a dynamic stack of skills, a collection of abilities you have to constantly build, update, and adapt. And this slide, wow, it just lays it all out, doesn't it? On the left, you've got the old way. Learn one job and you're set for life. But on the right, that's the new reality. You build a skill set for a lifetime. We're talking about a huge shift from just being stable in your job to being agile in your career.
You know, to really get how much has changed, we got to look at where we started. Traditionally, these roles were super defined. You were either an electrician general, the person who installs and maintains all the equipment, or you were an electrical fitter, the one who assembles and fits all the different parts. The lines were crystal clear.
Yeah, but that was then. Today, it's a completely different ballgame. Today's technician is also expected to be a network engineer who can set up enterprise-level Wi-Fi, a systems analyst who understands how industrial motors talk to the cloud, and even a coder who can write their own scripts to make their job easier. The job description hasn't just been updated, it's completely exploded.
So what are we actually talking about here? What's really in this new digital backpack? Let's open it up and take a look. We're going to treat the documents for this explainer like they're artifacts, pages pulled right from a technician's real digital files to see how all this knowledge gets layered, from the ground up.
And everything starts right here with the absolute non-negotiable language of safety. Before you can touch any piece of complex machinery, you have to be fluent in these visual cues. From the red circle that means, "Don't you dare do this," to the yellow triangle that's screaming, "Hey, there's a hazard here." What's so amazing is how universal this is. It doesn't matter if it's a simple light switch or a massive industrial system, these principles are the absolute bedrock.
And once you have that foundation, man, the jump in complexity is just immediate. It's steep. We go from these simple visual signs straight to the abstract math of AC circuits. This formula right here, it's basically the language of how electricity actually behaves in the real world, describing the relationship between different voltages in a circuit.
So you can see how this all fits together, right? There's a clear path. Step 1, you gotta master the theory. Step 2, you get your hands dirty and actually apply it in labs. And then finally, step 3, you take all those individual skills and you integrate them into one big functioning system. Let's see what that actually looks like.
All right, step 2. This is where the rubber meets the road. We're not just talking concepts anymore. We're talking about real, tangible skills. We're talking wiring up the control panels that run factories, using special tools to test cables buried underground, and even building the tiny logic circuits that are the foundation of, well, all modern computers. Every single one of these bullet points is its own world of expertise.
But then you hit step 3. And this is where you stop looking at just one component at a time and you start seeing how they all have to talk to each other across these huge interconnected systems. And believe me, the level of complexity here, it just goes through the roof.
And this table here, it just gives you a little taste of that. You've got smart motor controllers for factories, you've got enterprise-grade wireless controllers from a company like Cisco, and you have these incredibly complex safety standards. Now, you don't need to be an expert on any of this right now. The point is to just appreciate the sheer range of things a modern tech has to know how to navigate, sometimes all at once.
So, okay, you spend all this time acquiring this deep, complex, and often invisible knowledge. Which brings us to maybe the biggest challenge of all in a modern career. See, it's not enough to know all this stuff. You have to be able to prove you know it.
I mean, really, think about it for a second. How do you actually show an employer that you can troubleshoot a complex motor fault or configure a secure wireless network? These aren't things you can just list on a resume and have them believe you, right? So how do you make your expertise real, visible, and most importantly, verifiable?
And the answer from our case study is, it's kind of brilliant. You use one of your skills, in this case coding, to document and prove all of your other skills.
This little piece of code right here, Generate Portfolio, this is the secret sauce. It's a tool this technician built not to control a machine out in the world, but to control their own career story.
So what's it actually doing? Well, every single time our technician completes a task, let's say they test a circuit, this code logs it. It records the measurements, it links to the schematics or photos as evidence, and it even tracks their progress against formal qualifications. It automatically builds this rich, evidence-based portfolio of everything they can do. It's amazing.
And that, my friends, is what we call a meta skill. It's a skill that makes all your other skills more valuable. It's like a force multiplier. In this case, a little bit of basic coding became the meta skill that allowed this technician to systematically prove their expertise in dozens of other, much more complex areas.
Okay, so let's zoom out. This isn't just one person's story, right? What we're really looking at is a powerful blueprint. It's a model for how to build a career that's resilient, that's adaptable, and that's pretty much future-proof, no matter what field you're in.
And the blueprint itself is so simple, but so powerful. It's just 4 words. It's a loop. You learn, you apply, you document, and you adapt over and over again.
And that last part, adapt, that's really where the magic happens. As this chart shows, that solid foundation in electrical engineering, well, it becomes a launchpad into totally new and in-demand fields like cybersecurity or data analysis. The same logical thinking you use to troubleshoot a circuit can be the foundation for learning a coding language like Python. Your skills become portable.
So, this is it. This is the whole model, right here in a nutshell. It's got 3 parts. First, the mindset. You have to be committed to lifelong learning. Curiosity is your most valuable currency. Second, the action. It's that relentless cycle of learning, applying, and documenting your proof. And third, the tooling, which isn't just wrenches and screwdrivers anymore, but a digital portfolio, version control, and your own personal simulation labs.
Which really just brings us to one final critical question. And this isn't about electricians or engineers anymore. This is about all of us trying to navigate this world of constant change. So take a second and think about it. What skills, what tools, and what proofs are you packing for the journey ahead? What's in your career backpack?